A delta loop is one of the most effective and forgiving multi-band wire antennas you can build. While a standard half-wave dipole is notoriously stubborn when you try to use it on even harmonics, a full-wave delta loop is naturally resonant on its fundamental frequency and all of its subsequent harmonics. Here's a breakdown of the physics and electrical characteristics that allow a delta loop to function as a multi-band antenna. The primary reason a delta loop works on multiple bands lies in its full wave 1 lambda design at the fundamental frequency. A standard dipole is cut to a half wavelength 0.5 lambda. If you try to transmit on double the frequency, an even harmonic, the antenna becomes a full wavelength long, that is 1 lambda. At the center feed point of a 1 lambda wire, the voltage is at a maximum and the current is at a minimum, creating an extremely high feed point impedance, often several thousand ohms, that most tuners simply cannot match. A delta loop is a closed circuit cut to 1 lambda. When you double the frequency, the antenna becomes 2 full wavelengths long, that is 2 lambda. Triple the frequency and it becomes 3 lambda. Because it operates in all wavelength multiples, the current and voltage nodes align in a way that presents a much lower, more manageable impedance at the feed point across all those harmonic bands. While a delta loop is resonant on its harmonics, the feed point impedance is not a perfect 50 ohms across the board. At its fundamental frequency, a full wave loop typically presents an impedance of around 100 to 120 ohms. As you move up the harmonic bands, this impedance fluctuates depending on the band, your feed point location, and the height above ground, but it generally stays within 100 to 300 ohm range. Because this range is relatively low, you can use a 4:1 or 2:1 current balance at the feed point. This steps the impedance down close enough to 50 ohms that a standard internal transceiver antenna tuning unit or a dedicated automatic tuner can easily flatten the SWR for multi-band operation. When you operate a delta loop on its higher harmonic bands, the antenna physically becomes electrically longer, multiple wavelengths. This fundamentally changes how the RF radiates. Fundamental band. The radiation pattern is relatively simple. If fed at the bottom center, it pushes mostly high angle radiation, NVIS, which is great for regional contacts. Harmonic bands. As you move up in frequency, the single broad radiation lobe breaks up into multiple distinct lobes. The angles of radiation become progressively lower to the horizon. This makes a low band delta loop a surprisingly aggressive DX antenna on the higher bands. If you were to configure a full wave delta loop for 80 meter band, the total perimeter of the wire would be approximately 270 feet. Fundamental 3.5 MHz. It acts as a standard 1 lambda loop. Harmonics. Without changing the physical length of the wire, the exact same loop becomes 2 lambda antenna on 40 meter, that is 7 MHz, 4 lambda antenna on 20 meter, that is 14 MHz, a 6 lambda antenna on 15 meter, that is 21 MHz, and an 8 lambda antenna on 10 meter, that is 28 MHz. With a ladder line or a good balance paired with an ATU at the feed point, that single loop of wires strung up in the trees will load up and radiate efficiently across the entire HF spectrum. I have found that my 40 meter loop with homebrew ladder line, 4:1 transformer and ATU 100 gives me good results on all the higher amateur radio bands, including WARC bands and even 6 meter. In fact, it has the best near 1:1 SWR across almost whole of 10 meter band without a tuner.